Hi, my name is Cole Appin, and this is my lab report for the first physics lab in 2211. Um, Brief introduction. We'll be examining the momentum principle and Newton's first and second laws in practice, an explanation of the basic physics in the experiment, the comparison of the physical, calculated, and virtual models of the experiment, and I'll also be answering the what if and what does it mean questions. So the purpose of this lab is to observe the motion of an object that is moving at a constant speed without changing direction, which in this case I used a battery rolling along a table. We'll be applying the physics principles. So the basic physics used in this lab are Newton's first law. Objects in motion will stay in motion unless acted upon. Newton's second law. The force is proportional to the product of an object's mass and acceleration, which is F equals ma, force equals mass times acceleration. The momentum principle, which is P equals mv, or momentum equals mass times velocity. And then velocity and position. So velocity equals the change in position over the change in time, as well as the final velocity is equal to the initial velocity plus the net force divided by the mass times the change in time. So the system and surroundings. The system is the battery in this experiment. The surroundings would be the table, the air, the earth, and basically everything else in the universe. For the initial conditions, the battery is at rest. A brief look at the lab result. The battery traveled around 0.54 meters in 1.9 seconds. Calculated the velocity as 0.284 meters per second. We can use the Newton's first and second laws as well as the momentum principle to calculate velocity or predict motion based on my predetermined velocity. These are my models. The one on the left is the actual data, and the right is the predicted data. Here are them overlaid. As you can see, the position is pretty much the same. However, the physical data is not quite linear as the system and surroundings are not perfect, as other forces like friction are acting on the battery. The calculated data set is linear, indicating a constant velocity. Here is the Python model simulating the battery rolling at a constant velocity. As you can see, the calculated model shows the battery traveling around 0.54 meters in 1.9 seconds. This is the code I used for my model. I utilized the starter code but changed the velocity to the calculated velocity of 0.284 meters per second. For an overview of my experiment, I used roughly 58 data points over the course of the 1.9 seconds that the battery rolls. The battery traveled roughly 0.539 or 0.54 meters. Here's the tracker video of the battery rolling along the table. For the what if question, what if the axis flipped? For the video data and tracker, I oriented the axis to follow the battery's path along the x-axis without diverting. It was slightly off with some movement in the y direction due to the orientation of the camera. Changing or flipping the axis would cause the data to be inaccurate. The only thing I would do differently if I was to record again would to fix the camera orientation to be completely perpendicular and flat. For the what does it mean? There would be an initial push or force to set the object, the battery, in motion. After the initial push, the net force on the object is zero as no other outside forces are acting on the battery at that point. It's in motion. Therefore, the battery is moving at a constant velocity.